right, next question. We are asked to find the area in one petal of this graph. Now, the graph wasn't given, but you could have done that on Desmos or any other thing pretty easily. Here's the function. R equals cosine of 2 theta. And again, this is the sort of thing where there's a lot of heavy machinery involved, which is to say, it's a pretty darn complex question, but we're really going to use the machine to do the work for us, which is to say we're just going to use calculus. And the theorem in the book, let me cite the theorem. It is from section 1.4, and it is theorem 1.6. So this is from section 1.4, and it's theorem 1.6 here. Now, what do I have? What do I have here? Why do I have 0 to pi over 4? Well, look, when theta is 0, we're coming out here along the x-axis. And up here at pi over 4, I should make a better picture of this here like this. When theta is 0, we're here. As theta increases, we get that curve right there. And well, how do I know? I mean, that's pi over 4. How do we know that? I guess by symmetry, by looking at the picture. But if you think about it, when the angle is pi over 4, 2 times pi over 4 is pi over 2. And what's the value of cosine of pi over 2 is 0. And out over here, of course, it's 1. When theta is 0, cosine of 0 is 1. So if we find this area right here in the petal, we can just multiply by 8. We can multiply by 8. So let's go ahead and set up this integral right here. This tells us that the area is equal to 1/2 times the integral going from, remember this is theta, right? So that's why I wrote that there just to emphasize that. Theta goes from 0 to pi over 4 of r squared. Well, what is r is cosine? That's my dog barking there. So 2 theta d theta. And we have to do this integration. I think on the last problem I wrote down a formula for it from an integral table. And let's just say we didn't. I'll do it different this time. I'm going to use a trig table. And how about I don't trust my memory here? How about I go straight away and find that? Here's the little trig fact here. Let me write it over here. Cosine of something. Let's say, I don't know what letter I want to use here. Let's say cosine of a squared. This is equal to, hold on, I got to do a little math here while I'm at it, is cosine of 2x plus 1. Cosine of 2a plus 1 divided by 2. Yeah, okay. So we can use this to rewrite cosine squared as cosine. And once we get cosine, we should be able to integrate with no troubles. Let me just click back to where I can make sure I'm getting the stuff written on the board. So the a, I'll make a little note here somewhere. In this case right here, we're going to have a equal to 2 theta. So 2 theta. That's a bad choice. Well, maybe that's a bad choice. Oh, geez. I don't want this a to get confused with that a. So maybe let's call this, I don't know, w. So w like that. So what does this become? We get the area equals 1/2 times the integral from 0. I'm going to stop writing that to pi over 4 of, well, I've got to really be careful about doing this sort of thing here, right? So what is cosine of 2 theta? Well, whatever is the argument right there is going to go in right there. So we'll have cosine of, this is 2 times whatever goes here. So 2 times what here is 4 theta, and then plus 1, all divided by 2 d theta. We should be able to integrate this without too much trouble. Let me just, do this kind of thing here. I'll factor out a 1/2, and that'll make that a 1/4. And so we have to find the antiderivative. Reason the fundamental theorem of calculus. all the good stuff. What's the antiderivative there? Let's see, sine a 4 theta, and we need a 1/4 out in front. Double check that in your mind or what have you. And then plus theta. And this goes between 0 and pi over 4. Hey, don't want to forget at the end, we're going to multiply this by 8 because this is half of one of those petals. Or no, wait, I said find the area of one petal. So we'll multiply this by 2 when we're all done. So the area here is 1/4 times, well, if we put a pi over 4 in here, let's see, put a pi over 4, that would be sine of pi. Sine of pi is 0, so that would give you 0 plus pi over 4 minus. Now we'll put the 0 in there, put a 0 in there, all that business is 0, plus 0, we get this. And then area is 1/4 times pi over 4. And so that area is pi over 16, but we have to double it because that was just half a petal. So the area in one petal is equal to twice this, or pi over 8. Okay. I wonder how many of you noticed the error that I made in the last video. I don't know if I should point it out now or point it out in class. But when we were doing that integration, the curve actually got traced out in this direction, not in this direction. And one of the conditions on the area under a curve using parametric equations was that theorem held when x was increasing. If x is strictly decreasing, you had to put a negative sign in front of the integral. So ultimately, I arrived at the right answer. So, hey, there you have it. So where's the answer here? Here's the answer right here, pi over 8. Okay. It might be interesting check. I suppose it would be interesting check. Look, instead, suppose we had started the integral or the integration process down here when theta equals negative pi over 4. From negative pi over 4 to pi over 4, we get the whole petal, and we wouldn't multiply by 2. So let's just do that and see if we better get the same answer, or something, again, has gone terribly wrong. So I'm just going to swap in some different numbers here, negative pi, or just here, this limits of integration. And then here, this would be negative pi over 4. Now, where would it change things? Well, when I put the pi over 4, and that wouldn't change at all. What about when I put in negative pi over 4? If I put in negative pi over 4 here, we get negative pi. Sine of negative pi is still 0, so that's still 0. This, however, would be negative pi over 4. That would be negative pi over 4. And then I'd have pi over 4 minus a negative, so pi over 4 plus pi over 4. And what would you get here? I'll go off in this direction here and do it. We get pi over 4 plus pi over 4, which would be pi over 2. How come I'm not getting the same thing? Oh, because I forgot this 1/4. Sorry about that. Oops. Times 1/4. There we go. And that's pi over 8. And sure enough, that's the same thing we got a minute ago. So you could do it either way. It hardly makes a difference. And that's that problem. So that we'll come back with another video for the next question.